In this video, I'd like to explain to you how to calculate experimental yield, theoretical yield. So here's a bromination of cholesterol. Cholesterol is a complicated molecule with a number of stereogenic centers, and there's the alkene. It reacts with bromine to give you this, again, trans bromide, right, where the bromines are on opposite side. I'm not going to go into the stereochemistry here. Cholesterol's molar mass and formula are here, and all of the information is here on the board. Now, normally a procedure would say you're using an excess of something, like excess bromine is used, so we would know that that's the limiting reactant, and we use this number and this number to calculate the yield, all right? Now, I want to show you how to use the density as well, just in case you're doing this lab and you're using a notebook and having to fill in all the information, okay? Now, so what we're starting with is the circled quantities, and we get that in the lab, okay? So we're mixing 1 gram of cholesterol with 8 milliliters of bromine and the solvent and all of that to give us 1.21 grams of the brominated product. So what we need to do is calculate how many moles of cholesterol we have. And we do that by dividing by the molar mass. And so we divide by 386.65, and that will be the number of moles of cholesterol. Some professors and labs, they want you to do it in millimoles. I'm just going to do it in moles here, okay? So I get 2.59 millimoles, or 2.59 times 10 to the minus 3. Okay? For bromine, we don't have the mass because it's a liquid. We measure it more conveniently with a graduated cylinder. So let me show you how to calculate moles from a volume. So we have 8 milliliters. Okay. And the density is most often found in places like Wikipedia, ChemSpider, or even on the reagent bottle itself. So the density is 3.10 grams per milliliter. So we multiply the volume times the density, and we get, 24 grams, right? And then we do the same thing as before. We divide by the molar mass. And so let's punch all this into our calculator and see how many moles of bromine we have, okay? I get 0.15 moles. Now, chances are for your sophomore organic chemistry labs, the reaction's always going to be balanced with coefficients of 1. So if that's the case, we can just see which of these is a lower number. Cholesterol is the lower number, so that's going to be our limiting reactant, and that's going to determine how many moles of product we form here, okay? So you want to fill this information into your table that you're constructing for your lab. Now, to predict the theoretical yield, or how many moles of this we're going to form, it's going to be this many moles, okay? It's going to be 2.59 times 10 to the minus 3 moles, because there's a coefficient of 1 in both of these. So to figure out the theoretical yield, you do this. So we're starting with this many moles of cholesterol as our limiting reactant. And I'm just going to say 1 mole of the product per 1 mole of cholesterol. So if it's not 1-to-1, that's where you would do a different math. And then we want to multiply by the molar mass, okay? To go from grams to moles, we divide by molar mass. To go from moles to grams, you multiply by molar mass. So let's see how the units work. Now we want to use this number here. This is our product. It's 546.458 grams per mole. Okay, so the moles cancels here, and that's why you're multiplying by the molar mass there. So let's do this on a calculator. 2.59, 10 to the minus 3, okay, times 546.6, whoops, 2.59, 10 to the minus 3, times 546.458. And we get 1.42 grams. Now that number, so that's the product, and that's called our theoretical yield. If everything happens perfectly and 100% efficiently, according to the conservation of mass, we should get that. Now we didn't, all right? So to calculate your percent yield, you just calculate the ratio and you multiply it by. So this is the theoretical yield. To calculate the percent yield, it's going to be what you obtain in the experiment divided by the theoretical yield. And this portion right here is just telling you to express the decimal as a percent. It's easy to do that by multiplying by 100. So you take 1.21, divide by 1.42, and I get, that's wrong. I get 0.85 on my calculator. So you want to move the decimal place over 2 places. So just multiply by 100, and I get 85.2%. Okay. So if you're watching out for 3 sig figs, this has 2 sig figs, right? So probably we would want to report this out to 2 sig figs if most labs aren't really worried about significant figures, but you might want to go back and correct that if that's a point of your focus, okay? So that in a nutshell is how to calculate theoretical yield. I will next do it with a different example.